Retool is a platform to help engineers quickly build internal front ends. It does this by abstracting away repetitive aspects of front-end development. The platform was started in 2017 and has received funding from Sequoia, Stripe co-founders, and Nat Friedman. David Su is the founder and CEO of Retool. He joins the show to talk about why he started coding, studying philosophy and computer science, Retool's tech stack, and more. Pavel Barkowski is a tech lead and a software engineer with a background in launching products in startups and big companies. He's also the founder of Flat Social. Check out the show notes to follow Pavel on Twitter or LinkedIn, or visit his personal website, pavel.io.
Hi, David. Welcome to Software Engineering Daily.
Hey, really excited to be here.
So let's kick off with the first question. What is Retool?
Yeah, so Retool is a fast way for engineers to build internal front ends. The idea is that we as engineers, I'm an engineer too, we spend a lot of our time basically doing repetitive things in the front end, especially for internal tools. And so Retool kind of abstracts a lot of this stuff away.
And you started Retool, and I was wondering, in the early days, how did you get into programming and what were your first steps in the software industry? How did it start?
Yeah, so that's pretty interesting. So let's see. When I first started programming, I was initially maybe, I don't know, like between the ages of 10 and 13, more of a gamer. And so when I was gaming, I eventually got into building my own PCs basically. But this is just like, putting things in the motherboard, loading the motherboard into the chassis, so pretty basic stuff basically. And at some point I was like, well, this hardware stuff is pretty interesting. I was overclocking my PC, I was trying to, undervolt it, a little bit to keep the heat down, et cetera. I was doing all those, fun hardware things. But at some point I was like, hey, it would be really cool actually to get to the software side too. And the reason for that is mostly because this was going to sound kind of trite, but it really is true. I looked at sort of the impact the software was having on the world. So at around this time, this is probably when the Arab Spring happened. And so if you remember, this is sort of when Twitter was taking over the world. And it was remarkable to me that Twitter, which was a company, I think not that big at that point, maybe 50, 100 people or something, was in San Francisco, which is actually not far from where I grew up, actually toppling a dictator, halfway around the world, actually. And I was like, wow, the impact of software is really phenomenal. And if I want to, sort of create a positive change in the world, software really seems like the way to do it. And so that's when I started thinking, hey, I should learn how to code, basically. And when I first learned how to code, I wanted to say that I first learned via a book called SICP. So it's, I think, the Structure and Interpretation of Computer Programs. It basically teaches you how to code, and in Lisp, actually. And so Lisp was a pretty interesting language because it's not super practical. I think people use Clojure and ClojureScript today, but Lisp itself is Scheme, I should say, is not a super practical language to be coding in today. But it really actually taught me the fundamentals of programming, which is really interesting. And actually, then a few years later, I went on to study comp sci and philosophy, actually, at Oxford. And at Oxford, actually, the first language they teach you there is actually Haskell. And so that was also a, pretty interesting first language. And the second language is Scala. And Scala, is kind of functional and, Java-like in some ways too. So functional programming is actually still one of my passions, if you will. Just yesterday, for example, I think there was an article in Hacker News about currying, for example. And I was reminiscing about how, cool currying is in Haskell. And it's, too bad that there are actually a lot of, it's kind of funny. There are a lot of comments on that article saying currying is stupid and, it makes code really difficult to read and Haskell sucks. But, to me, it's at least, for a sort of programming language to learn from, it's really interesting because it's a totally different paradigm, if you will. So.
And did you find like you and your older classmates, did you have in the beginning, was it a big change for you to think the Haskell way? Or did you grasp it quickly?
I actually don't know what percent of the comp ski class knew programming before. If I had to guess, it's like 50-50, honestly. So actually, I think a lot of people who were studying CS had not actually coded anything before. And so for them, it's like, well, Haskell's just the way you code. And then actually then going to something like the more imperative language, like a Scala was actually kind of shocking. It's like, hey, what do you mean? It's you tell the computer to do things instead of just, declaring it to be so. So that actually was a little bit stranger, probably going for functional declarative. So I think most people did not have that much coding experience, actually. For me, I think after I learned Scheme and Lisp, I think I then did learn Python. And Python was, I think, a lot easier to code in, but it was like, to get any problem done, basically. But I actually found it far less interesting because I think it's far less mathematical, if you will. So, Like when you finish a Scheme program and, you feel really good about it. When you finish a Python program, it's like, oh, cool. Okay. Am I proud of the code? Like, it's okay.
And how did you find, because you said you studied computing science with philosophy. I don't know if in US you can have combinations like this, because I know that in UK it's quite common. For example, my degree, which was in AI, had 2 first years. We had all of the psychology courses. So we did all the modules in psychology, which was very interesting. And I kind of see a little bit maybe of a similar thing here. And how did you find studying philosophy with computing science? And how did it affect your maybe thinking in the future? And it just was different.
Yeah, so it is. So that's actually the main reason why I ended up in the UK for university, was because of the degree specifically. I was actually pretty lucky to have found it, because comp sci and philosophy, I think it was the year I did it, it was actually the second year it was ever offered, actually. And I think maybe Oxford has introduced maybe like 2 degrees in the past, 100 years. So it was, really lucky that I sort of just got there just in time. If I were born 3 years earlier, I would not have been able to study it, actually. So that was really quite lucky. And that was actually the main draw, was that it was actually 1 degree, which is, kind of like what you studied, perhaps. It was really cool because I think in the US and in many other schools, you can actually choose to major in, 2 things if you really want to, if you're ambitious, for example. But the 2 things that you choose to major in, they're not really going to be related. You're not going to have many courses in the middle, if you will, covering the 2, separate majors you chose. Whereas actually at Oxford, this specific degree actually was 1 degree. So it was computer science and philosophy together. And that was really quite interesting to me, because I had always wanted to study. I had actually wanted to major in philosophy. I actually was probably on that path, actually, of wanting to major in philosophy and actually not comp sci. And the reason was, I had already taught myself how to code. And so, kind of figured that teaching yourself to code was not that hard. And so I didn't necessarily need to study it, basically. Whereas philosophy, it seems like it's going to be more discourse based, for example. And so actually having other people study it with and talk about it with would be more interesting. Whereas comp sci, you run programs, you compile them, and, it's correct or not, right? So, but then I found this program and I was like, wow, this is really what I want to do. And people oftentimes ask sort of what is the intersection between computer science and philosophy, because it's not obvious to some people actually where the intersection is. The intersection is probably in 2 places. One, sounds like you're very familiar with, which is AI. AI was much less hot back in the day. Back in the day, I think it was mostly around machine learning. It was what most people were interested in. I think in 2013, when I started studying it, I think that's when neural nets had just sort of been able to score, relatively high on MNIST. And MNIST was like the handwritten digits. So basically people, handwrite 1, 2, 3, 4, 5, all the way up to 9, and the neural net could recognize it. And that was like the state of the art for machine learning, So it wasn't, as hot as it is now. But specifically what the intersection between comp sci and philosophy is as it relates to AI was basically what are the limitations of a computer, and can a computer think? And that's actually, really quite relevant today, because if you look at the Turing test, for example, I think Alan Turing said that if you can converse with a computer and the, computer types responses back to you, and you as a human cannot tell if it's human or computer, then the computer has, achieved human level thought, basically. And, there's no difference between a computer and a human. And today, I think with LLMs, they certainly have. So the LLM certainly passed the Turing test, without a doubt. Like, actually, at this point, I sometimes suspect the humans that interact with actually are computers, actually. So it's kind of turned around, which is kind of funny.
You can think that.
Yeah. So that, I think, is one area, sort of, what is the limitation of a computer, basically? And, are humans just, biological computers, if you will? So that's, one pretty interesting area. The second really interesting area that I'm actually more passionate about is actually logic. And logic is basically the underpinnings, if you will, of both philosophy and computer science. And so, for example, philosophical logic, maybe the most simple version of it is you try to formalize concepts about the world. So maybe it's like, hey, the sky is blue, and, is P, and, Q is, the sky is red, for example. And, P and Q are contradictory. So P and Q cannot be true together, for example. So that is the underpinnings of logic, philosophical logic, but also the underpinnings of computer science, actually. If you sort of think about how computers work, actually, it's really quite comparable. So,
yeah, I think it's an interesting kind of, and the parallel paths, but they do cross occasionally, right? It's an interesting, definitely, to study. I was wondering, from all of this, how did you end up working on Retool? Where did the idea come from? And what was this kind of beginning of Retool as an idea and as a company?
Yeah, so Retool started mostly because my co-founder and I were both engineers, and we were working on a bunch of side projects. And every side project we worked on, we always needed to go build internal tools for. And to give you an example, one of the side projects that was probably the most successful one was we basically launched a sort of P2P payments product in Oxford. And if you're from the area, you'll know that in the UK, for example, it's actually quite hard to send money back and forth, actually. I think nowadays with Monzo, for example, with the Revolut, it might be a bit easier. But the traditional way people send money is basically by memorizing the account number and a sort code, basically. And you send the money, and the money, I think, takes like 2 hours or something to arrive, typically. And so one of our ideas was, hey, what if we made a faster, electronic way, basically, of sending money, and we can keep balances in the app, and, then sending money is just incrementing, decrementing a balance. So it's, effectively instant, basically. And so we did that. So we built it, and we were like, hey, for fun, now that we've built it, might as well launch it, basically. And so we launched it. And what was really cool is actually we got 70 or 80% of the school, actually, the university actually using, at least undergrads at least, using the product weekly. So that's, pretty cool. But then we quickly realized that now that people are actually using this product, we have to go build internal tools for it, actually. And so that project probably lasted somewhere between 3 and 6 months. And I think we literally spent, half our time, if not more, literally building internal tools, just day in and day out, basically. They're kind of the tools you can imagine. So tools to, for example, manage withdrawals, tools to manage fraud. There's a lot of fraud, as you can imagine, with sort of a P2P payments app. And so we built a lot of tools to go detect fraud, for example, to sort of, see the network, basically, and who's sending money to who and stuff like that. And we're building all these tools. We built a bunch of tools before too. There's a lot of these sort of front-end CRUD apps basically before for other side projects. We quickly came to the realization that actually building these tools is extremely repetitive and it's extremely boring. And I think if you ask most engineers, for example, what part of the job do they hate the most, as a software engineer? Honestly, it's probably writing tests and building internal tools. That's probably it, actually. And the reason why both of these are so boring, or why sort of both these tasks are so hated, is because it's so repetitive. And so specifically on building internal tools, one thing to think about is if you think about building, let's say, a form, for example, that submits a post request to your backend API, for example, like a pretty common, internal tool, internal UI, if you will. That form is actually surprisingly hard to build. It's pretty easy to get a sort of initial version working very quickly. And if you use HTML, for example, it's very simple to get a form going. But then, let's say you want to display a loading indicator, for example, when you press the submit button, hypothetically, because you don't want people pressing the submit button 5 times. It's submitting 5 times, right? So like, hey, well, I want to disable the show load indicator and disable the button. Well, to do that, you can't just, use a predetermined amount of seconds or milliseconds. You actually have to say, hey, I need to track state, right? So you need to track actually, is the API request pending, for example. And let's say you're doing this in React, you're like, okay, well, now I got to go import Redux, actually. And Redux is a pretty complicated library to understand. You're looking at, let me track that in Redux. I've got to track is fetching in Redux, for example. And then let's say it displays an error message back, for example. Okay, well, now I got to, track the error message in Redux, for example. And then I got to go find a, toast library, for example, to go display the error message. Maybe I got to worry about authentication into my backend endpoint because there's authentication. Probably have to worry about authorization. If you're like, hey, I want certain people to be able to submit this form, but not everyone, for example. So I have to worry about authorization of the front end, for example. So there's a lot of work basically that goes into building a pretty simple form. And the really annoying thing about this is actually all internal tools, every form you build kind of needs these similar things, right? Like every form you build probably should have a submit button that gets disabled after you press it. It should probably go display error messages in a toast, for example. And so that's kind of what gave us the idea for Retool, which is why is it that we're coding in such a low level way? Like, is there sort of a higher level way of coding? And that led us basically to Retool. One thing I will add, which I think is pretty interesting, and it's a common misconception about Retool, is that Retool is probably, I think, 90% of the time used by software engineers. And this is actually very controversial when we first got started, because people would say, hey, software engineers already know how to build internal tools. So why are you making it, better for them? Why not allow everyone to go build internal tools? Why not, go allow non-engineers to go code, for example? Why not democratize software engineering, which sounds really pretty sexy? But for us, our hypothesis, we were software engineers ourselves, our hypothesis always was that actually, if you build something like a no-code tool, for sort of non-engineers, you basically really lose out on power and flexibility. And that's actually why engineers hate these no-code tools. I'm an engineer too. I hate using a no-code tool. And the reason why that is because I know it's not going to be powerful enough. I know that, when I need to do something that is even slightly more complicated than what the company had in mind, I'm going to hit a brick wall, basically. And so an example is, let's say you're using Zapier, a no-code tool, for example. Let's say that I want to branch on, if the input is even or odd, for example, which doesn't sound that hard. I better hope that in Zapier they have an even or odd function, because if they don't have an even or odd function, I'm screwed. I can't use Zapier anymore, basically. And maybe they have an even or odd function. But maybe I want to say, hey, can I mod 7, for example? Well, they probably don't have a modulo function. Maybe they have even or odd, but they don't have mod 7, And so then it's like, well, I hit a brick wall. I can't do anything, right? And so we as engineers really hated the sort of feeling of being boxed in or not having power and flexibility. And so with Retool, we actually very intentionally focus on software engineers. And the hypothesis basically is that we can get you to 80% of what you want very quickly. And the last 20%, we always give you the escape hatch where you can always write JavaScript wherever you want, basically, or go import your custom React component or go write Python even. And, so for us, we're quite engineering first, which is actually very surprising to a lot of people.
So would you think that simplifying the complexity of building software for the people who cannot code will create even more complexity and kind of open a Pandora box of maybe different issues and problems and, and the product would get massively complicated?
Exactly. Yeah. So the way we think about it is that there is irreducible complexity in programming, and code is the best way to attack that irreducible complexity. So for example, like the mod 7 thing, right? Like if you had to do that in a visual way, let's say inside Zapier, if it was possible, like you would be like, okay, we'll have a node, maybe like case 1 go over here, case 2 go over here. It's like, so complicated basically. Whereas in code, it's very easy. You can just say, hey, I don't know, n equals the variable mod 7, for example. And then you say, hey, switch n, and then, case 1, case 2, case 3. Like it's so much simpler to write that in code than to try to, use a GUI to write that basically. Or to try to
you end up with like a massive tree and almost like
it's hard to read and, it's hard to reason about and it's hard to fold the code, so code is actually really quite good. But we just think there should be less of it. And so I think an analogy here that, we often tell, that actually customers sometimes tell us, is we sort of think about programming, 30, 40 years ago, for example. I mean, I've programmed assembly myself too. And, I don't know if you have, but like assembly, it's pretty hardcore. You can go right to assembly if you want. But honestly, in most cases, like you don't need assembly. Most programmers today, I would argue, are not programming assembly anymore. If you're building, let's say, I don't know, maybe if you're programming the International Space Station, for example, maybe you're very memory constrained, for example, and you're working in tech that's, the computer itself, that's the chip that's running it is like 50 years old. So maybe you have to program in a very specific, very low level way, for example. But most engineers who are solving business problems don't need to be programming in such a low-level way, basically. And so if you look at the evolution of programming languages, we move from like assembly to, for example, interactive terminals, and then higher-level languages like a C, for example, eventually C++, like a Java, something like that. Today, like a Python, Ruby, JavaScript, these are much higher-level languages, basically. But if you think about it, though, in the past 20 years, there actually has not been sort of another leap forward in programming, basically. And so the idea is that might we look back at engineering today or programming today the way that we look back on, assembly, for example, today, which is, in 20 years' time, people will be like, wow, I cannot believe that I used to program in such a low-level way where I was so worried about, hey, let me go make sure, that when I press the button, I set as fetching to be true. And then, when API request returns, I set as fetching to be false. I, capture the error message. I display it in the toast. Like, what if you don't have to worry about any of that? So you can actually focus on what is specific to you and your business, actually, or your problem, which is probably not like, hey, how do I track the state? Instead, it's actually, hey, what should be going in the form, for example? When the form returns this kind of error, what should I display to the user? Like, that is, code that is specific to you and your problem. And that's the code that you should be writing. All this other stuff, it's kind of just boilerplate, basically. There's no reason for you to be writing it. So that's kind of the core idea.
And to create new bugs, just rebuilding. It doesn't matter if you build the form 20 times, in the past year, there's still possibility to introduce new bugs. And if you have a tool that's a little bit higher level, I would imagine that kind of not only speeds the work up, also removes an entire spectrum of issues that could happen.
Yeah,
especially
exactly.
with complicated elements like tables.
Yeah. And the really cool thing is that we can give you actually good defaults. So, speaking of the table component, for example, tables are, as you just noted, they're really complex, especially when you sort of load a lot of data into it, for example. So you have to worry about like, how do I virtualize rows? How do I virtualize columns for big data sets, for example? How do I do filtering? How do I do group bys? All these things are actually pretty hard things. But if you use Retool, we actually can give you all these defaults out of the box. And I think one interesting thing about Retool too is that we are really only focused on internal software and internal UIs. And the reason for that is we think React might actually be the correct level of abstraction if you're building something really complicated. So let's say you're building Airbnb.com, for example, which is like a, pretty complicated website. It's got to be highly performant. It's highly customized. The design has to be just exactly perfect. Animation's exactly perfect, etc. In those cases, actually, maybe React is perfect for the job because you need to customize, in a really deep way. However, if you're building Airbnb's internal tools, do they need to be as perfect as Airbnb.com? Probably not, actually, because a lot of the internal tools, actually, Airbnb is a customer of Retool. A lot of their tools are actually in spreadsheets. And in spreadsheets, it's super easy to make mistakes. And the reason why it's in spreadsheets is because they don't have time, they don't have the engineers to go build good software via actual programming, basically, and build, actual applications as opposed to spreadsheets. And so that's what Retool is really tackling is there a class of software, and we think there is there some percent of software, basically, that we think could be built in a higher level way? That's effectively what Retool is focused on.
So when I have worked on internal tools actually with very old and kind of long-lasting corporations, I have seen those monstrous Excel spreadsheets many times. And quite often we've been called to, okay, here's this very intelligent employee that we have, but it's not their job to code. So the only tool they had at their disposal was Excel. So they just put all their mind power into creating the most complicated Excel spreadsheet that could have been solved with software, but instead is solved with Excel. Like the use of Excel, even for internal tools, I think it's pretty high still.
It's super high. I mean, probably some large percent, maybe like 30, 40% of internal tools that people are building in Retool today are basically replacing Excel spreadsheets or spreadsheets more generally. And I think what's weird, I mean, and curious to hear your thoughts on this too, is that so many of these older companies literally run on these spreadsheets, even though the technology behind React, for example, or even databases have been around forever. But I think it's just like you said, there's just like such a large class of people who are able to code in Excel. And so there's so many Excel spreadsheets that are already built and they're so hard to maintain, but it's just, what exists. And so it just has a lot of momentum, if you will. But as you know, like Excel is really crappy. It's very easy to make a mistake. If you accidentally press one wrong button, for example, it may not be obvious, but your whole spreadsheet might actually be broken. Or maybe there are insidious mistakes you can make if you add an extra zero, for example. I think there's so many stories of, businesses making huge mistakes because they, add an extra zero to the spreadsheet, for example. And so that I think is sort of the power of software. Yeah, like really you should be running your business on custom software, not spreadsheets. It's just that custom software today is so expensive to build and so boring to build for an engineer too. So
I would imagine quite often, given that how expensive it is to build software and the amount of time that you need to invest, and also the amount of proficiency you need to have to build, for example, frontend, like using React. Like you cannot expect, a business analyst to go and just build like amazing React application. I think quite often what might happen within those teams is that somebody has a problem that they need to solve, but they are not, for example, within a large corporation. They would need to ask for a developer to be assigned or a development team to take care of this. And they want to be more independent. So they grab the tool they have on their hand and they do the best with what they have and then just pile up more and more things on top of that Excel spreadsheet.
Yeah, totally. I'm trying to think like what the biggest Excel spreadsheet retools replaced. It's probably been like in the orders of hundreds of megabytes, actually. So like you can imagine that's a pretty big Excel spreadsheet. And you can imagine if you actually have a custom, UI for that and actually the data in a database, for example, how much better that is. I mean, it's much more performant. It's much easier to collaborate. You can actually version track control all the changes, etc. So yeah, it's kind of remarkable.
Yeah, if multiple people work on the same spreadsheet, oh my God.
I mean, you have like V77, V78.
Yeah. Just imagine the amount of issues that result from that. And you also spoke with SED back in 2020. So if whoever is listening and wants to listen to the previous episode as well, I think that if they type in Retool into SED's website, then they should be able to find it. So I was wondering what happened since then and what changed?
Wow. Yeah, 2020 was a long time ago. I think Retool has probably grown a bit more than 10x in basically all useful metrics. So for example, whether it's revenue, number of customers, number of apps built, et cetera, et cetera. So that's been really exciting for us. For me, I think the most energizing thing about Retool is seeing use cases that people have built inside of Retool. And the use cases that people now build today are just so remarkable, ranging, for example, from a company like NBC, who actually schedules the Olympics, actually, via Retool. They basically want to figure out like, hey, at what point do we want to show what event in order to maximize viewership for the US time zone compared to, the European time zone, for example. Amazon, for example, is now a customer. They actually literally use Retool to control satellites in space. So they like press buttons on the Retool application and satellites actually move, which is really cool. So, it's really remarkable sort of seeing what kind of software people have built in Retool. And it's that to me is the most energizing part. So
it kind of feels like it's almost like creating a new programming language that then you can see what people create, using this programming language.
Yeah, exactly. Yeah. That I think is sort of what makes it, for me at least, so interesting to work on Retool, because you're not sort of building software, you're almost building like meta software, basically, right? Because you're building software that allows other people to go build software. And so the problems that we face are not like the problems of, hey, this app is not ideal or, whatever else. It's like, how do we create an application that allows people to go build, really good applications? And so that's really pretty interesting.
So just imagine, for example, from like a very practical way of thinking, that imagine that I'm building a new real estate business and I have to create, like a website with listings. of all of the apartments that I'm selling, potentially a notification system for all of the employees and to use within the organization itself. And I was wondering how Retool could help and thinking through what elements from Retool could I use? What kind of workflows maybe? Is there anything ready that I could use as a startup, let's say within this area, for example, to build the backend?
Yeah, so what we see now, if you're a startup, is that actually a lot of people basically prototype and retool to sort of get a first version of an application you're talking about there. Because to be honest, I'm an engineer, you're an engineer. I think if we built that app together, for example, it wouldn't take that long. Maybe it would take a week or something, maybe a day for a particular screen, and you have to figure out the database schema, et cetera. So it wouldn't take an enormously amount of time. It would take a week. But then what gets challenging is when you start talking to customers, because the customers have a lot of ideas about what you could add. Maybe you talk to the realtors. The realtor's like, hey, I want to be able to add, so for example, in the US, the law is actually recently changing about sales commissions actually on real estate. And so maybe the realtor's like, hey, I want actually a way to specify the commission that I charge, for example. And so okay, well, now let me go modify the front end, go add a text input. I have to go build a backend system. I have to go build a sort of, admin tool basically to actually say hey, I don't want people consumers, be able to modify this, obviously. It's only modifiable by either me or the realtor, for example. So you have to go build a back office tool for that. And then you talk to more customers. Maybe let's say a prospective home buyer is like, hey, what I want to see is my distance to work, for example. Mm-hmm. And distance to work is, probably not a component that you've built because it's prototyping, right? But hey, the customer wants it, so you should go build it basically. And so what we have noticed now is that people actually, especially startups, will basically prototype their startup in Retool because it allows them to move very quickly. So instead of taking a week to get, a V1 out, maybe it takes a day actually. And you hit the customer and you say, hey customer, what do you want basically? And the reason why this is so powerful, I think, for the startup using Retool is because the reason most startups die is not because of engineering or engineering capabilities. That's generally not why startups don't succeed. Instead, the startup probably fails because they couldn't find product market fit and they couldn't build something what customers wanted fast enough or they ran out of money, basically, or ran out of energy. And so what's really exciting about Retool is they could iterate extremely rapidly on, hey, I talked to a customer, they said they wanted extra button here, an hour later, boom, it's done, basically. So that, I think, sort of that extra, iteration speed is really exciting. So that's, how a startup might use Retool. For a larger company, what they typically do is they actually build sort of a lot of these back office or sort of, I think for a larger company, they wouldn't actually call it these internal tools because internal tools are actually primarily what they work on all day, actually. They call it more like a business app, for example. And so maybe some portion of the business says, hey, I want an app, for example, that will allow me to allow salespeople to input their forecast for the quarter, for example. And I want this app deployed to 1,000 salespeople, for example. Then, that's a pretty good Retool use case because that's, in the end, basically a CRUD app. It's a CRUD app that you email to 1,000 people, and maybe you have to remind them to fill it out if they don't fill it out. So you can use the backend workflows product. It's just kind of like a cron in the cloud, basically. So you can use that to remind them. You can build the front end very quickly in Retool, probably in a day or two. You can deploy on-prem, so it's very secure, for example. They could get the app shipped very quickly. And so that is probably how sort of a larger company might use something like Retool.
So also thinking from building the internal tools at large companies, if I'll be introducing, for example, Retool to one of the companies that I have worked at, probably one of the first questions will be the security. Because if the data is related to business, if it's sensitive, especially within large corporations, and also granular access and is needed to that data. So what steps do you take to make sure that the use of Retool can be secure and safe within large organizations?
Yeah, great question. So this is where I think actually the fact that both my co-founder and I were developers actually really made a big difference. Because as developers, we typically don't want to copy your data anywhere. We want to store data at one place and have one source of truth, for example. Second is we don't want to trust anyone because trusting anyone is, in general is a bad idea. And so we basically want to minimize who we talk to overall. And so this actually led to a couple of design philosophies for Retool that were actually pretty interesting. So in the former, Retool never stores any data. We basically connect to your data no matter where it is. So whether it's in your backend API, for example, or a database, whatever it is, we connect to it. This is very different from actually most no-code tools. If you think about an Airtable, for example, or a Notion. Airtable and Notion both store data, right? And the major challenge with them is if you want to, let's say, use Airtable to edit the data you have in Salesforce, for example, the only thing you can do is, or database like Postgres, for example, the only way is to build a two-way ETL sync. And a two-way ETL sync is as an engineer, you don't want to build that. So many ways for things to go wrong, basically. So for us, we always come to data no matter where it is. So that I think is, one major differentiator. The second, that's pretty interesting, is that we allow you to self-host Retool. And that was always very important to us. And the reason for that is especially when this is probably more true when Retool first started out. Today, we have great companies, like an Amazon, NBC, et cetera, using us. But back in the day, none of these people used us, right? And so to actually gain their trust, what we had to do is we could say, hey, you can actually, Retool is just a Docker image. You can host it, however you want. And in fact, if you want, you can actually air gap it. And if you air gap it, if you think about it, basically, this is really no different from running, for example, like a Kafka, for example, or even like a Redis, something like that, right? Like basically, it's a service you run on your own cloud with a Docker image, and you control everything. And it's actually air gapped, so no data can go in and out, basically. And so then you're not really trusting Retool at all. I mean, I guess theoretically, if you ship really bad code, we could maybe drop your database, that's probably the worst thing that could happen. But no matter what, data could never surface to the outside world, basically. And so that to us was really pretty important. And so actually, we, I think, launched Retool, and then I think a month later had on-prem, actually, because we got this feedback from customers. And I think on-prem is getting more popular today. But actually, I think we were probably the first developer tools company, I think, to really embrace on-prem in this way. Part of it is timing related. I think we were just lucky that we started Retool in 2017 when Docker was just, getting more and more popular. And so it was just really easy for us to ship Retool on-prem. So.
And I was wondering, as a developer as well, whether in corporation or in startup, if I would want to introduce Retool to my product as a part kind of the back office of my product or as an internal tool, how do I pay? What's the pricing? Do you price per usage? And also, if I use it on-prem, does the pricing differ?
Yeah. What happens generally when people want to use Retool is it's actually free to get started. And so you can just use it. You can download it. We have a Docker image. You can download yourself if you want, actually. So on-prem or cloud, you can do whatever you want. Both are free. I think it's free for up to 5 users or something. So it's basically very easy for you to get started, prototype your app, etc. basically. If you go past 5 users, what we do is we charge a price per developer and a much lower price per end user. And so I think the developer, it's like $10 or $50 per month. So even the developer is not that expensive. And the end user is something like, I think like $5 or $10 a month. And so it's, fairly cheap to get started. And if you're a really big company, like for example, actually today, 5 out of the Fortune 10 are Retool customers today. And so, that gives you a sense sort of, how well adopted Retool is today, which is, something we're really proud of. They generally have pretty custom pricing plans. If you want to roll out Retool to 10,000 people, for example, I think we have one Retool customer that rolled it out to, I want to say 100,000 people actually. And so then the cost per user, I think it's like $1 or something like that. It's really very cheap, basically. So
would that be the 100,000 people, but this will be running on-prem?
I would imagine they run it on-prem. Yeah.
So looking at the cost, but also from the perspective of how much time do you save, do you maybe have any idea or opinion? Obviously, this is just, a general question. What is the cost of not using Retool?
So we've actually run surveys on this to sort of compare, every time you build an app in Retool, we later on we'll send you a survey asking you, hey, how much time did you save? And the reason why we ask for this is because it's sort of good to keep ourselves honest, basically. Because if Retool's not actually saving you any time, then, we should probably really re-examine what the product is doing, basically. I would say in general, we probably save you anywhere between 5 and 10x of the time spent on building a product. And the reason for that is, as having worked at a big company, a lot of the time in building a product is actually not just the building itself, but actually it's the iteration to the end product, basically. And so what's really powerful about Retool is that, let's say your customer, for example, is a total customer, maybe it's like the sales team, for example, maybe like a VP of sales wants you to go build this forecasting app, for example. Typically, what would happen is you would get some specs, you get some requirements, you build it, and you ship it to them. They're like, hey, these 5 things are not right. So, then you have to, respec or, go rebuild these things, basically. With Retool, what's really cool is actually you can actually sit next to this customer and be like, hey, what do you want, actually? And you can literally build the application live with them, actually. And so it really cuts down on sort of the feedback cycle and sort of the iteration loop. And so a project that, might take 3 months, for example, without Retool, honestly probably would take, I don't know, maybe like 5 days, so maybe even 20x faster or something like that. And we see that with many customers. There are some cases where Retool is actually slower, though. In particular, for example, if you're looking to build something where you really care about the look and feel. So if you're building like Airbnb.com, for example, I'm pretty sure that if you try building Airbnb.com in React, for example, versus Retool, it would be slower in Retool. And so there are a few examples like that where there are things that Retool is bad at, basically. But I think if you are building a CRUD UI, Retool's without a question, I think something like 5 to 10 times faster.
So we talk a lot about how to build things using Retool, but let's talk a little bit about how Retool is built. So I was wondering, what's your tech stack? Did anything change since 2020? Is there anything that you use that maybe other companies don't use that you find very useful? Is there any advice on the technology used?
So I think what's maybe really funny, if you will, about Retool is when we first started working on Retool, actually, we built a lot of internal tools actually in ClojureScript. And the reason why that is the case is because we were looking to, make building internal tools more interesting. Because we were like, building a CRUD UI is very boring. So why don't we try to learn a new framework, new language, while we're at it, basically.
Two birds with one stone.
Yeah, it was kind of fun, actually. But today, I would say Retool is a pretty typical, 2024, if you will, tech stack. And the reason for that is it makes hiring, for example, a lot easier because I think considered using ClojureScript actually on the front end for Retool as well. But it would make hiring really hard because the pool of, engineers you can hire becomes way smaller if you're comparing React to ClojureScript, for example, or JavaScript, I should say. So today, let's see, Retool is basically TypeScript mostly on the front end. We use React on the front end, and on the back end, it's Node, although we're looking to rewrite some of the stuff in Java, actually. So yeah, pretty typical, not too interesting tech stack, if you will. There are maybe the front end, for example, or the front end tech stack, if you will. We used to use more off-the-shelf components. So I think we used to use Ant Design, for example, for most of our components. We're now moving to actually building that actually totally in-house. And the rationale behind that is something like a Ant Design or, like any Material UI or any one of these libraries. They're actually not very well built for internal tools. And internal tools, for example, you care more about performance, you care more about speed, you care more about informational density, for example. And these things are actually not, for example, what a Material UI is really optimized for. And so we're looking to bring some of that stuff in-house, but pretty typical, tech stack.
How large is your engineering team in respect to the size of the entire company?
Yeah, so the EPD, so engineering product design together is around a third of the company, maybe around 36% of the company. Engineering itself is probably around 27% of the company, roundabout.
So, would it be majority would be JavaScript developers, like full stack JavaScript developers that they can use and move quickly between different projects?
Yeah, exactly. So they work on both the front end and the back end. We're generally organized in terms of product teams because we find that sort of leads to higher velocity. So we don't have a front end team or a back end team. Instead, it's just hey, if we ship a feature, it's the whole, you can sort of work on any part of the stack, basically. One challenge I will say is we have found it challenging to hire front end developers for whatever reason. I think it's too bad that I think it almost feels like front end engineering as a craft is not as big as it should be. I think part of the reason for that is because most front end is pretty boring at most companies. Because if you think about the average company, even the average Silicon Valley company, for example, front end is it's not generally cutting edge, if you will. If you go look at, I don't know, even, very popular companies today, like an OpenAI, for example, or if you look at all the AI companies, I don't think they're doing anything really interesting on the front end. If you look at most companies that have been founded in the past 10 years, I don't know, you can look like a Dropbox, for example. It's not much for front end there. You can look like an Instacart, DoorDash, there's a bit of front end, but it's not too deep. I think we have really challenging front-end problems. So, for example, I'd probably say it's similar to Figma in terms of front-end challenges. And so we're really looking for front-end engineers. So if you're listening and you're a front-end engineer, please do reach out. That's probably the area where we really need talent the most. So
I always found the front-end engineering with JavaScript a little bit like this zoo that you enter and there's different animals and each single one of them is different. So all the frameworks, all the different patterns that people use, somebody might use TypeScript, somebody might just use the vanilla JavaScript. There's still a lot of people on Twitter just voting for only using jQuery and just plain HTML for the.
Oh, it's old school.
It's very old school, but then at the same time, from the perspective of how this is done, at the end of the day, it's about creating the great experience. And me as a user, do I really care if the great experience has been used jQuery, or did somebody create React in React and then added, some additional CSS framework on top of it? I think it's about performance and the great experience at the end.
Yeah, totally. And I think this kind of gets to maybe the core idea behind Retool is that in the past 20 years, I think programming has maybe more moved sideways than it has gone up and up, if you will. It's kind of crazy that we're still talking about, why not build the app in jQuery? The fact is, actually, jQuery actually has some advantages actually over React because it's conceptually extremely simple. It's not that many lines of code, actually. Whereas in React, even when you sort of spin up a boilerplate React app, I think it imports 20, 30 different node modules. You're like, well, what do these things do? I have no idea, honestly. But actually optimizing performance of React is a lot harder than optimizing performance of jQuery. jQuery out of the box is actually quite fast. So it's actually kind of surprising there's been basically programming has not gotten any better in the past 20 or 30, at least front end development has not gotten substantially better in the past 20 or 30 years. And it's kind of funny that we're still looking at, how good things worked, 20 years ago when it was just jQuery, for example. And that's what Retool is really hoping to change is that we hope that when we look at this era of programming, we don't think this is the global maximum of programming. We don't think we've achieved, the peak programming state, if you will. We think there's like another evolution or two left, basically. And we hope that Retool can be a big part of that. Is there a much better, faster way of building software? At least for a sort of subset of software, we think definitely. So.
And I was wondering, in continuing a little bit on how Retool is built, what was the biggest technical challenge in building Retool, and how did you overcome it?
Yeah, so I think this is a pretty interesting story. I wouldn't necessarily say it's an interesting technical challenge, but it was a pretty big surprise, if you will, from our side. And so what happened was, this is when Retool was maybe around a year old. So what happened was we were deploying to a pretty big company. So we're on-prem, and it's a pretty big company. Their actual chief security officer reached out to us and actually said Retool is very insecure. And we did, security audit, and it's insecure. And we're like, why is it so insecure? And he said, basically, actually, we don't trust our developers. And the way that you've built Retool, so effectively how Retool works, we touched on this a little bit, but sort of it's a programming environment where you can build the applications. The developer builds the application Retool, basically. And when you build the application, you can sort of use curly braces. And it's kind of like actually JSX, for example. If you use a curly brace, for example, you can go run JavaScript, with a curly brace, and it is run, right? So in our case, just like in React, if you sort of write JavaScript in that way, it is run on the front end, which makes sense. So the user who is using the application then sort of will run that JavaScript, basically, that is within our curly braces. And this is actually what makes Retool so powerful, because if we don't support something, you're like, hey, no problem. I can go run my own JavaScript. I can go import, a library, whatever. You can write, custom JS everywhere in Retool, basically. So it's very powerful. However, this CISO basically said, hey, the problem is that we don't trust our developers. And so what if, for example, we have a malicious developer, actually, that actually writes, for example, some malicious JavaScript? Because this runs on the front end, you have access, for example, to cookies, for example. So I could actually siphon off your cookies, for example, the user's cookies, and actually send them to my backend API, or, a separate, malicious backend API, for example. And so what happened then is actually, let's say a malicious attacker could, for example, build this application that siphons cookies out. They could send it actually to everyone in the company. And now he would actually, as a malicious developer, he or she would actually then have the cookies actually for Retool for actually all these different users actually. So now this malicious developer could actually go impersonate all the different users, for example. So maybe they could impersonate, for example, the CTO of the company. The CTO of the company maybe has has more permissions than this person does on Retool. And maybe, with this person's permissions, they could, delete apps, for example. Maybe they could add more, backdoors to apps, maybe, do all sorts of bad things basically. And so this is, kind of interesting because, for us, we were like, developers, you kind of have to trust your developers, right? Like if you don't trust your developer, like isn't it kind of game over anyways? But actually, at a big company, at a large 100,000 person company, actually, you don't trust all your developers, or you trust them in different ways, right? And so maybe you trust this developer with this portion of the code base, but you don't trust, if they make a commit, if this other part of the code base, you don't trust them, et cetera, right? So it was really pretty interesting. And so we're like, wow, that's, actually a really different way of thinking about, because we were thinking like, hey, maybe you don't trust the end users, maybe the end users will do something bad. But actually in this case, the company didn't trust the developers. It's the way past all this is basically you have to sandbox all the JavaScript you run. And so today, all the JavaScript that is run in Retool, if you run it within a curly brace, it's not run within sort of the Retool context. It's run within actually a separate tab, basically. And so, in a separate tab, that tab is, a sandbox. And so it doesn't actually have access to, for example, the cookies that you might have on Retool.com, for example. And so that I think was actually that was a pretty early, if you will, technical challenge. And, sandboxing in itself is actually not that hard. But then the question is like, how do you do message passing, for example? Because, for example, maybe someone wants to calculate, inside this JavaScript actually something really big. Maybe they want to pass in like 100,000 rows of data, for example. They want to do a sum. So then, how do you compress the, it gets pretty interesting, basically. And so, yeah, so that was a pretty early security or technical challenge that actually really surprised us because, we had never worked at such a big company where we actually don't trust the developers, if you will. So that was a pretty fun
also
challenge.
Quite often what happens is that companies, they hire not only permanent employees, but also contractors. And then the contractors are there, for example, for like 2-3 months. Let's just get this project out of the way. And then not always they are, even though that, at least in UK as a contractor, you have to have insurance. So if you really break something, that you can take responsibility for it. But I would imagine that it's better not to break it.
Indeed.
And beforehand. So I understand it and this lack of trust a little bit. I think, but it's not something that the first thing that comes to your mind, planning for the positive, effect.
Yeah, totally. Yeah.
At which point did you realize that Retool will succeed? Was there any within the growth of the company or any user that you spoke with that you had this aha moment? I'm like, okay, this is going to go well.
Wow. The answer is definitely no, because I still don't think Retool succeeded yet, actually. So to give you a sense, I mean, we have a good amount of revenue, but the mission of the company, we really want to affect change in how software is built. We want to bring good software to everyone is actually the mission for the company. And we want to do so by actually changing the way developers build software. And if you look at what percent of software is internal facing in the world, we think that probably something like 50% of all software is internal facing. And if you're based in Silicon Valley, this might sound kind of surprising to you because, Silicon Valley companies typically sell software. And so, most software they build is external facing software. But if you, for example, have worked at a, large company, most companies in the world are not software companies, and so most companies in the world, like many of our customers, if you look, for example, at like Coca-Cola, for example, Coca-Cola is not a software company, right? I mean, they sell drinks, they sell beverages. And most software engineers in the world actually work at these non-software companies, basically building internal tools day in and day out. And so we think half of the software in the world is internal facing. And that's what Retool is really targeted at. And if you look at what percent of even that software, what percent of, internal software is being built in Retool today, man, I mean, I think it's grown 10x, as we know, we chatted last time on Software Engineering Daily, but even growing 10x, like even today, it's, maybe like 0.1% today, of all internal software is built in Retool today, as opposed to 0.01%, which is maybe where I was, let's say, 4 years ago, right? So it's also that it's grown 10x, but, I think it's like 100 or 1,000x more it could grow actually. And so until we do that, I hope that, when we look back in 10, 20 years, we'll be like, wow, I really cannot believe that we programmed in such a low-level way. And Retool is sort of a major push towards, can we sort of make building these internal apps a lot faster, a lot better, a lot easier for engineers. I hope we can say, hey, Retool actually played a large part in that. And so if you look at it, as our mission, I mean, we're a failure, so I hope that we will eventually become a success, but it's pretty far away. So
we come back in 3 years, ask you the same question again. And
maybe we'll be, a few X larger, but
So it seems like there is a SaaS platform for everything those days. And do you think that we will see users drifting away from those vertical SaaS application per problem kind of solutions into more general tools?
Yeah. So I think what's interesting now is that a lot of companies are realizing they've bought a lot of SaaS software. And oftentimes, especially if you're an engineer, I'm an engineer, like if you look at the SaaS software, you're like, man, how hard could it be to build this thing in-house? Like it's probably not that hard, basically. And the fact that you're buying SaaS not only does it cost you money, but it also is not really customizable. A lot of our SaaS products we try really hard to customize in-house, but it's not possible, right? Because it's not a programming environment, basically. So this, I think, is sort of a cool thing about Retool as well, is that part of the mission for us too is that can we make it so easy to build internal software, custom internal software, that actually you want to build more of it. And this is, I think, maybe an overly grandiose analogy, but I think it's the core of it is true, which is if you compare Retool to like a printing press, for example, like you could argue that the immediate effect of the printing press is that it makes it cheaper to print books, which it's true. But like that's not the ultimate effect of the printing press, right? It's not just cheaper to print books. Instead, it's actually that because it's so cheap to print books, everyone can go write a book, for example. Now knowledge can be spread very rapidly. And so that's really the impact of the printing press. And similarly, we think with Retool, what could be really cool is not only is it cheaper to build internal apps, but because it's cheap to build internal apps, hopefully developers will build a lot more custom applications actually that are really bespoke to their business and can solve their business problems really well. And as a result of that, companies themselves will run a lot better actually, because instead of having, to run in a giant Excel spreadsheet or running a software that, it doesn't really fit, the way you operate, now you can actually have custom homegrown software. And so that to me, I think is, really exciting too. And I think we see that a lot actually with Retool use cases today. So
that could potentially replace a lot of the SaaS subscriptions that were solving any small problems separately with Retool.
Yeah. But I think even more broadly, if you think about it, one sort of like use case that I'm really proud of is there's just not enough software engineers in the world. And so there are a lot of really interesting problems in the world that are not being solved today because there's just not enough software engineers to go and solve it. So actually one customer that I'm really excited about, I actually had them come to our all hands maybe around a year ago or something. Is this customer called Fund for Guaranteed Income. Basically, it's like a UBI, so Universal Basic Income, basically. And they're actually running a UBI study in a city in California, actually. And for them, they actually can't afford to hire software engineers because they're a nonprofit. They don't have extreme amount of funding. And for them, they probably will not be able to run their UBI project. They would not be able to actually hand money out. They actually track, who's received money this week. How are they doing? What's their level of happiness, for example? What do they use the money on? All these things. They track all that via Retool. And it's all automated. A lot of it is automated. And there's no way they could have done that with spreadsheets. They could not have automated all this with spreadsheets. And so that's an example where like the world needs more good software. And there's not enough of it, actually. And so that I think is really exciting to me about sort of the mission for Retool is can we bring good software to everyone by making it a lot cheaper to go develop custom software. So
and to free developers for coding up another form.
Yeah, exactly.
Another table. And what are you working on right now?
So one thing I'm really proud of at Retool is I think we've built a culture of shipping very fast. So if you go look at our changelog, for example, you'll see that actually, I think, every month we ship a lot of new things. There are quite a few things we're really proud of that we're working on right now. So one of them is incorporating AI, for example, more into the product. And so one thing for us that is pretty exciting, sort of allowing AI to actually automate business processes. So I think there's a lot of talk about agents, for example, in the AI world. And I think the models currently today are not quite there, and they may not get there actually for a while, I think. And the reason for that is because today the models are very good at solving smaller, medium-sized problems. Maybe, small, medium problems. And so it's like, hey, do this one thing, and if it's tightly scoped, the model can do a good job. But if you're like, take over the world, for example, the model's like, I don't know how to take over the world. Like, it's really confusing to me, basically. Or even like solve the support ticket. The model might be like, oh, I'm kind of confused. There's so many ways I could go. I don't know how to do it, basically. And so for us, or one thing that we're really excited about working on is actually sort of this workflows product that allows you to sort of, allows you as a human to go define actually, hey, let me go break this problem down into like, 17 different small size problems. And then maybe each one of these small size problems actually can be done via AI. That I think will really allow people to harness the power of AI a lot more. Because I actually don't think that AI is, very good at saying, hey, here are the seven. I think there are a bunch of experiments on the chain of thought stuff, for example. But even that, gets kind of tricky when the number of steps gets too high or the complexity gets too high. And so really, we think that maybe actually humans or programmers are the ones that are good at sort of this like high level engineering of like, hey, do this, then do this, and in this case, go over this way, in this case, go over this way. And then all the individual steps can be handled by AI. Maybe some of the transitions can also be handled by AI too, for example. And so I think that's actually really missing right now. It's sort of, there's no good sort of framework, if you will, to abstract these business problems in a sort of soluble way for AIs, if you will. And so that is something that we're working on right now that I'm really pretty pumped about.
Like splitting a larger task into smaller tasks. So for example,
exactly.
And take over the world, we need to eat first, then we need to plan, then do this and that. And then tackling the smaller tasks kind of as more digestible chunks that AI, the current state of AI can actually take.
Yeah, exactly. Yeah.
No, that makes absolute sense because for like smaller tasks might be executed and even just use humans to kind of fill the tasks that couldn't be done. Yeah. And I was wondering, as a company, how do you work? Are you all based in the same place? Are you all in the same office? Do you have any team members working remotely?
Yeah, so we do have some remote team members, but Retool is primarily office-based, and we are in SF, New York, and London. The reason why we're primarily office-based, we actually really do believe in remote work. So actually, you could say we're hybrid. I mean, we're in the office 3 days a week and then not in the office 2 days of the week. And hybrid work, I think, actually could work, or even remote work could work quite well for a larger company. The reason why we're not fully remote is mostly because we're a small company. And I think for a small company, a lot of the sort of personal relationships you build, I mean, today Retool is only 300 or so people, is really fostered by being in the office, actually. It's much easier to collaborate. It's much easier to go run into someone in the hallway and actually talk about a project that you two are probably both working on. I think in a larger company, if you're a 100,000 person company, you probably have multiple offices anyways, the benefits are greatly diminished. But I think for a small company like us, it actually is really important that people are really close and tightly knit. And so part of that is being in the office together.
And speaking about the team, you said before, you mentioned that you're hiring. So there's the audience here, I think, is largely technical. So if you're hiring for any positions?
Oh, yeah. I will hire for practically all engineering positions. I think the one that we've talked about a bit already is really front-end engineering. And front-end engineering, I think we'd be pretty open to honestly hiring anywhere for, because I think front-end engineering talent is also pretty distributed as well. So yeah, if you're a front-end engineer, please do reach out. I mean, I think we have really, really exciting front-end engineering problems, ranging from, how do you optimize performance for really complicated Retool apps, for example, but also how do you build a, programming language that by default allows you to build really good applications, whether that's performance or UI or whatever else. I really think that when I compare Retool to other companies, I think Retool is probably in the top, maybe 1 percentile in terms of like challenging problems that we have in the front end.
On the front end.
Retool's, it's a app that allows you to build CRUD apps. And so it's actually really quite deep and quite complicated on the front end. So
the front end to rule the front ends and to build the front ends. And I was wondering, also looking into the future, where do you see Retool in 5-10 years?
Yeah, well, so like I talked a bit about in our mission, our mission is twofold. One is to sort of bring good software to everyone, which is how do we arm, all the companies and all the people in the world with really good software so they can go achieve their aims. That to me is pretty exciting. And I think there's this old Steve Jobs line. I think it's like, what is the mission of Apple, basically? And the mission of Apple, I think computing overall is kind of an abstract thing. Like, what's the purpose of computing, basically? And I think what Steve Jobs said was, hey, we want to allow every one of our customers to sort of put a dent in their corner of the universe. And that to me is really exciting too. And that's why Retool is, I think, so exciting to a lot of the people that work here, is because we are building tools that allow other people to go build the applications and to power their business and to power their lives, basically, and allow them to sort of achieve things and achieve their missions, actually, which is really cool. So that's, I think, one thing, one area. So we basically want to see more applications or more software that is being built that would not have been built via Retool, basically. And, a kind of interesting way of tracking that is sort of what percent of the software in the world is built via Retool. And so, like you said, I hope that in 3 years' time, I'll come back into Software Engineering Daily and say, hey, actually 1% of all software today is built via Retool. And that software would not have been built without it, actually. And so I'm really proud of the impact that Retool's having on the world. And so, yeah, that's the goal.
Personally, I'll be definitely trying Retool on the next project that I'm working on right now, because I already see a couple places where I can free myself up from, the forums and the tables and actually focus on the external part of the app.
Yeah, let me know what your feedback is. So
definitely will. Awesome, David. Thank you so much for your time. It was great talking with you.
Yeah, thanks so much for having me. Excited to be back and maybe see you in 3 years. So